lesson, we were doing something called tree diagram questions, where the tree diagram allows us to understand the different events that can happen, and it allows us to calculate the probability of certain events happening in a way that's more straightforward and clear than if it was just sort of we were randomly doing it. And so if I ask you this initial question, actually, we've done this one already. Let me go on to the next one. Okay, so let's do this one over here. It's a little bit more wordy, and we don't need to answer every question yet. But what I want you to do is consider the following situation. A bag contains 3 red balls, 2 blue balls, and 5 white balls. And a ball is selected, and its color is noted, and then it's replaced. A second ball is selected, its color is noted, and then it's replaced. So the first question I want to ask you is, are these 2 events independent? Yes or no? Okay. So I see Dawn is locked in her answer. Anybody else have an idea as to why they are or not independent? So they are independent because we put the ball back in to the box or the container, the probabilities do not really change. They don't affect each other because you go back to essentially the same state as before. So event A, let's say drawing the first time, doesn't affect the result of event B. However, later in this lesson, we will do a situation where we take a ball out and we don't put it back. And at that time, those events are no longer independent anymore because you've taken one of them out. And so you've changed, the first event has changed the probabilities for the second event. Okay, let's just start with this. Draw me a tree diagram to illustrate the above situation. And so I want to give you 1 minute to 2 minutes to draw me the tree diagram for this with the probabilities on the tree diagram. However, if you do not know how to do that yet, say, for example, if you were completely new, then maybe just pop your hand up or let me know in the chat. But for now, I want us to try and see, can we draw the tree diagram? And then after we've done that, we'll talk about answering the questions. It's kind of like our warm-up question. So we're only drawing 2 balls. We do replace them, but I'm trying to understand what are the different options that are available to me. And so how many branches must the first level of my tree have? And how many branches must the second level have? That's the sort of tip I'm going to give you. And when you're done with your tree diagram and you've written the probabilities in, you can just type in the chat tree done, so I know whether or not your tree is done yet. Oh, actually, that's a bit crowded for that one. So this is... Okay. So if I look at the possible outcomes, Now, they don't always ask you to show the outcomes, but the first outcome would be RR or red, red. The second outcome would be red, blue, and so on. You can see them from the branches on the tree. Now, I want to ask, what is the probability of selecting 2 blue balls? So let's start with that. What is the probability of selecting 2 blue balls in this particular situation? You take a moment to think which branch of the tree relates to blue balls or 2 blue balls, and then what is the how would I calculate that probability? So that's the choosing blue initially, and here is choosing blue for a second time. And so I think it would just be 2/10 times 2/10, which would equal 4/100, or 1/25, which is what I'm seeing in the chat, or 0.04 is also fine as well. Okay, so that was the first one. I want to know now, what is the probability, of selecting a blue ball and then a white ball? So a blue ball and then a white ball. So what pathway would that be? A blue ball and then a white ball would be that one. And so I'll just do the answer down here. It looks to me like 2/10 times 5/10, 10/100, 1/10. Yeah. Okay. 1/10 is the correct answer for the second one. And it's just choosing the right pathway. I'm going to do one more question from the warm-up, and then we're going to move on. What is the probability of selecting 2 balls of the same color? So what is the probability of selecting 2 balls of the same color? I'm skipping to doing just this question. What's this going to be? Which pathways am I looking for that give me a favorable outcome for this question? Oh, I'm taking away the wrong thing here. I suppose I want red, red. That could be the same color. I could have blue, blue. Or I could have white, white. So what is the probability of selecting 2 balls of the same color? Well, I suppose I just need to know the probability of each of these branches and add them up. So 3/10 times 3/10 plus 2/10 times 2/10 plus 5/10 times 5/10. And what is that going to give me in total? Yeah, it's going to be 38/100 or 19/50. Okay, now that's a pretty decent question. So if most of us are okay with that, we can move on to a different type of question, but just give me a quick thumbs up, thumbs down. Thumbs up if you're feeling okay, thumbs down if you're like, ish. Just want to get a quick. Okay. So what we're going to move on to now is we're going to move on to a slightly different situation. We're going to talk about the situation where we draw without replacing. Now, what happens is, let's consider the situation as a first example. Now, if we are taking a ball out and we're not replacing it, it does affect the probabilities of what is drawn on the second event. And so those events are no longer independent. But the good news is we can still use the tree diagram structure. So this is the question, and we'll do it together. Consider a jar containing 7 red balls and 4 blue balls. 2 balls are selected and are not replaced. This means that the first ball is not returned to the jar before the second ball is selected. Draw a tree diagram to represent the situation. So what is happening in this question is we're still drawing 2 balls. So I think the tree diagram can still be like this, right? So there's only 2 different colors. There's red and blue and red and blue. So this part of the tree diagram will not change. And if you think about it, does the very first draw, does that change in any way? So give me a thumbs up if you think it's, how would I say that? So say yes or no. So does the first draw get affected in any way in this question? So yes, if it does get affected, or no. Okay, it doesn't get affected because you haven't taken anything out yet. So what's the probability of getting a red? It's just going to be 7 out of 11, because there were 7 red and there were 4 blue. So the chance of getting a red is 7 out of 11 and blue is 4 out of 11. Now, this is where it gets a little bit more exciting. Your first draw is exactly the same as it would have been in the previous question in terms of process. However, the second one is slightly different. And I want you to think, how do you think it's going to be different? Does anybody have an idea as to how they think it would be different? How do you think it would be different? How many balls are there going to be in the jar when you, say, for example, you drew a red on the first go? How many things are there going to be in the container for your second draw? How many are there going to be? They're going to be 10, exactly. So your fraction is no longer going to be 11, it's going to be out of 10. However, if you chose a red on your first draw, how many reds are left for your second draw? What do you guys think is, how many reds are left in the bag? It's going to be 6. Oh, my thing just took off. Sorry, let me bring it back. So you're quite right. This is going to be 6 out of 10. Now, if we look at the other branch below the red, there's still going to be 10 items left in the pot for the second draw. But how many blue ones? Because you didn't choose a blue in your first go, this is still going to be 4 out of 10. And you'll notice that 6 out of 10 and 4 out of 10 still gives you 1. Now let's go to the blue. Let's imagine that instead of choosing a red to start with, I chose a blue. So it was 4 out of 11. But now I'm choosing on my second go, what is the probability of choosing a red on my second go on this branch? What's that going to be? So it's going to be out of 10, definitely, because you've taken one thing out. But because you didn't choose a red when you first started here, this is going to be 7 out of 10. So that's going to be 7 out of 10 chance of getting a red because you took a blue one out. And so there's 7 reds left and there are 10 in total. What is this branch going to be? Yeah, 3 out of 10. So the good news is it's not actually that different to the other stuff you've been doing. It just means when you don't replace the second ball, you have to change the numbers on the second branch to adjust for that. However, when we get to calculating the probabilities, the good old tree diagram is still our friend. So let's try and do that now. What is the probability for this question where you're not replacing the balls that both balls are red? In fact, you can do both of these, both 1 and 2. You can work them out in one time. So what is the probability that both balls are red? And what is the probability that the first one is red and the second one is blue? Take a moment to think about that. So for red, I think it would be this pathway. And so to calculate the probability of the outcome RR, all I do is I go 7 over 11 times 6 over 10. And according to my calculations, that should be 42 over 110 or 21 over 55. What about the second one, red, blue? What's that going to be? It's going to be a different pathway. Red, blue is going to be that pathway. So it should be 7 over 11 times 4 over 10. Which is 14 over 55. Now, all right, now I want you to do the third one. What is the probability that at least one of the balls is red? So ask yourself, how many of the branches will be included, and what would the answer be to 3? Two red and one blue. No, so what they mean, Kevin, is that they're saying the first ball is red and the second ball is blue. So it's just it's this pathway over here for your question. But now the third one is saying at least one of the balls is red. So they're saying if there's any red in the pathway, it's included. So red is included, red blue is included, and blue red. Those all 3 outcomes are favorable outcomes for this question. So what is the probability going to be then? I think it's just going to be the sum of these 3 branches, because at least one of the balls is red. So at least means we include the red one. So I think we just go, the one branch is going to be like that. So that's this branch over here. And then we have that branch over there. And then the last one times 7 over 10. And you should get 98 over 110 or 49 over 55. So whenever you have multiple branches on the tree, you do need to add up each of those probabilities. So what this is saying is 49 out of 55, there is a really, really good chance that when you're drawing these 2 balls from the jar, that you're going to get some red, because like essentially there's a lot of red balls in there. And so there's a very high chance that you will get red on one of those two balls. So I just want to stop for a moment. Any questions or comments from the class? Thumbs up if you're feeling okay. Thumbs down if you're feeling a bit overwhelmed. Just want to get a quick. So Kakleko was asked, can we use the idea of going subtracting? So you could, Kakleko, instead of adding up the 3, what you could have also done is you could have found the one branch that it's not, and then gone 1 minus, and that would have given you the same answer. So that's completely fine. Let's squeeze in one more question before the break. So this is quite similar to a previous question. So it says a bag contains 12 red and 5 blue. A ball is drawn at random and not replaced. Then you take another ball. What is the probability that they're both red? So over to you guys. I'm not going to say too much other than to say good luck. If you are stuck, ask a question, but it's time to fly solo.
Go for it, guys.
See if you can do it. So think about what are the steps that you need to go through. Yeah, and if there are any questions, now is a great time to ask questions because, yeah, I'm available and happy to. It feels to me like red and blue. The problem is, what are the numbers? That's the problem. Okay, so this is where it gets a bit trickier. If I've chosen red, so I know it's going to be out of 16. It's also going to be out of 16. And I've taken out 1 red, so that should be 11. But I've taken out no blues, so that's 5. So notice how, this is the difficult part. Notice how I got 11 out of 16. So the red went down by 1 because I chose that. And the 16 is going to be the same, but this stays at 5 because it wasn't. And then for the blue, it's out of 16. But now this is going to be 12. And then this one over here is going to be, you took a blue out. And so 5, you took a blue out, so this should be 4. Now, of all the pathways, which ones are the ones that I'm interested in? I'm actually only interested in a red, which is that one there. And so what do I get? What's the probability of red? To me, it should just be 12 over 17 times 11 over 16, which is, I'll pick my answers here, 33 over 68. There we go. I'll put that in the background, or maybe I'll put it below. That helps. So you should get 33 out of 68 for your answer. A question, yeah. Whose hand is up? Let's have a look. Inam, what's your question, Inam?
Good day, sir.
Hey,
So if a question comes out saying if there's a probability where two balls were chosen at a random and they were both not replaced, would you subtract 2 from the total, sir?
okay, so both were not replaced.
Yes,
You
sir.
subtract. So you don't, this is the situation here. Then you would need to, I'm trying to think of trying to imagine a question like that. I haven't seen one. Maybe what you could do is send it to me, because I can't recall a question quite like that, if I'm honest. Yeah, somehow can't really imagine what you're saying right now. But I'm happy to look at a question if you can email it to me. Cool. All right. I want to modify this question though. I do want to add one more little bit before we have a break. What is the probability that you draw basically balls that are the same color? So I want to take this question. You can see the answer on the board. What is the probability that the two balls that you draw are the same color? I want to know what the answer for that is before we have our break. Oh, Dawn is saying, I think instead of one ball being drawn at the same time, it would be 2 at the same time. Oh, okay. Dawn, essentially, that situation is covered by this situation. So if they say draw 2 balls at the same time, it basically means one of them was taken out slightly before the other one. And so it has the same structure. Thank you. I understand the question now much better. There's only 2 types of questions that you'll be asked. The one is where you replace them. The other one is where you don't. And if you're not replacing, you'll use this method because one will always be taken out a little bit before the other. Don't know if that helps a little bit. Okay, so what is the probability that they have the same color? So all you need to do is add this one and that one, which would give you, what's that going to be? It's going to be 33 over 68 plus 5 over 68, 38 over 68, or 19 over 34. So that's the probability of having the same color, or either red, red, or blue, blue.
Good work, guys.
Awesome. I like what I'm seeing. Like what I'm seeing. So I pushed you hard. It's now time for that stretching break. So what I want you to do is I want you to stand up with me, turn on your camera, and just let your body have a break. Because you've been working hard and you deserve it. So I'm going to drink a toast to you.
Come on, guys. Please join us in the stretch.
Have
Give
a
your
water.
body and mind a break. You've done such hard work.
And just give a little stretch.
Kevin says,
Time for exercise. Yep. Oh, I can't tell you how happy this exercise is making me. You should have FOMO if you're not stretching. Oh, this is fantastic. Oh, and shake it out. Shake it out. Let's do this. I feel like one of those gym instructors. Woo! Okay, and shake it out. There we go. Get the blood moving around. Ah, that feels so good. So good. I hope that you've had a stretch wherever you are. And I know what you are thinking about now. What is the brain break question for today? And so here it is. What is the maximum number of times you can subtract 5 from the number 25? That is the challenge for today. And see if you can do that. Okay, well, let's take 25 and let's take away 5. Aha. So 25 take away 5 is 20. Can I take 5 away? Oh. So I was a little bit sneaky. And so the correct answer is going to be this. The correct answer is once. Because when you take away 5 from 25, it becomes 20. And so you can only take away 5 once. All right. So the correct answer is 1. That's it.
It caught me out as well, guys. Don't worry about
Watch out.
it.
These brain breaks lately have been quite sneaky with their wording. So I think I'm gonna, yeah. But I hope you understand kind of what I was going for there. Tricky, I know. I do like, I'm not gonna lie, like I do like it when I find a question that has a little spice with it. It kind of just, keeps it interesting. So I do look for that. Okay, so let us go on to a past exam question. So let's have a look at this. So I want you to try and do this old exam question for me. I don't know why this is frozen there. So let's see if I can enlarge this. Yeah. Over to you guys. So are there any questions? I think everyone is focusing hard. See if you can get 5 out of 5 for this question. When you think you've got the answer for 8.1.2, then you can just put it in the chat. If you've got a question, just raise your hand. I'm happy to talk through it. A couple of different answers coming through. Let's keep them coming. What do you think the answer is? Okay, so I'll give you a little bit of a hint here. Or maybe I should draw the branches. It's probably better if I draw the branches to show you instead of just kind of putting up the answers like that. So first step, there are only 2 colors, right? So we know that that's going to be blue and red, blue and red, blue and red. We know it's out of 5. And so this will be 3 out of 5, and this will be 2 out of 5. We know that if I chose blue to start with, it's going to be 2 out of 4 here, and it's going to be 2 out of 4 here. If I chose red to start with, it's still going to be out of 4, but this is going to be 1 out of 4 now. And then over here, it's going to be out of 4, but I chose a red. Wait. It means 1 out of 4. This is a lie. So I've got 4 things left. How many of them are blue? I've got 3 out of 4. If I chose a red to start with, I then have, I've taken 1 red out, which means I've got 1 left. I've got 1 out of 4 like that. Okay, so now I have to ask myself, what is the probability of first taking a red marble and then taking a blue marble? So that would be this pathway here. And so that would be 2 over 5 times 3 over 4, which is 6 over 20, which is the same as 3 over 10, or 30%. So there's a 30% chance. Okay. Any questions or comments about that? Are you, because these are getting a little bit tougher. Sihawu, let's go to you. Yeah.
Hi, sir.
Hey. What can I do for you?
Sir, I have a question. I have a question for the red, like at the bottom, where it
Yeah.
says a second marble is taken from the bag. The color is recorded and then put aside. Wouldn't the total be 3 instead of 4? Because they took out 1 from the 4 that was left.
So it depends on what they're taking out. If they're taking out red first, you've only got 4 left in either option. But because you took out a red, the original amount of blue are still left in the bag. So that's why this is a 3. But with the red option, because you took a red out to start with, you have to take away 1. And that's why this is going to be a 1 over here. Does that sort of make sense?
No, sir, I'm talking about the denominator.
Oh, because when they say put it aside, they mean it doesn't go back into the bag. It's put aside. It's not back in the bag.
So, sir, shouldn't it be 3 instead of 4? Because from the 4, they took a second marble and they put it aside.
No. So it's just the wording that I think you're getting confused on. So it's put aside. It's the same as the previous question in terms of the wording.
Okay, sir, thank you.
Pleasure. Okay, let's do another one of these. So let's try and do this. A bag contains 1 blue, 2 green, and 3 red. So I want you to try and draw the tree diagram for this. And then let's start by trying to do at least the first 2 questions. Okay, so over to you guys. Think about the choices that are involved. And let's go from, let's just do those 2 there. So remember, we're trying to do both 1 and 2. I see some of you have got the answers. And then if I choose a red one to start with, 1 out of 5. Okay, so for the first one, we want to know what's the probability of getting 2 blue branches or 2 blue cubes. And you can see, I suppose logically it makes sense too. Hey, like 1/6 times 0/5 is going to be 0. But it also makes sense logically in the sense that if you only have 1 blue cube and you take it out, what's the chance of getting a second blue cube? It's impossible. You can't, because there was only 1 to start with. What is the probability of 2 red cubes being taken? And let's add one more to the list. Let's also ask, what's the probability that at least 1 green cube is taken? So for RR, 2 red cubes, it's just going to be 3/6 times 1/5. 3/6 times 1/5, which is going to be 3/30, which I'm assuming is, what do you guys get? You guys are getting, why are we getting a different answer? 3/6? Sorry, I lied. It's not 3/6. It's red, red. Yeah, 1/5. So have a quick look. I see some of you are getting different answers for the second one. Aha, let's have a quick look. So 2 red cubes are taken. Oh, you're quite right. It's 3/6 times 2/5. Yeah. So I didn't. If you look at my diagram, 3/6 and then 2/5. That's why this should be 3/6 and 2/5. Thank you for spotting that. So it's not 3/30. It's going to be 6/30, which is 1/5. Happy days. Okay, what's the last one? It is going to be at least 1 green cube is taken. So it's actually going to be quite a few of these. It's going to be, okay, so I'm going to stick with the color yellow, I guess. Or what color should I use? Let's use purple. So at least 1, but it includes 2. So this would have a green. So that one over there would have a green. And all of these ones would have a green. And that one over there would have a green. So there are 4 branches that would have a green in them. So how would you get the answer to that? Is the question. And then I think we're going to finish for tonight at that point. We can go and do the quiz. So at least 1 green cube is taken. At least 1 means we still include the situation where it's green, green. So there isn't 5 branches. Well, let me pull up the answers for this one just to make sure it is 5. Right, that's 3. Yeah, so it should be all if you look at the answers, there should be 5 branches. It's going to be this one, that one, that one, that one, and that one. Okay, so let's get the final answer. So the final answer is going to be 1/6 times 2/5 plus 2/6 times 1/5 for that bit, plus, let's make sure 2/6, 1/5, plus 2/6 times 3/5, plus 3/6 times 2/5. Okay, so I'm going to pull up my answers because I think it's a bit of a mouthful, this last one, but you should get 3/5 as the final answer. Let me I'll copy and paste this working so you can see it, and then we'll bring it to a close here. Hopefully you can then see it more clearly. Flip. Okay, it's not coming through as clearly as I hope. Let me move it down then. So your final answer is basically 3/5. It's this one down here. It looks more complicated when you look at it in terms of, and okay, so the other thing you could have done is you could have gone 1 minus the branches that do not have green in, and you'll get the same answer. Yeah.